One rainy afternoon, three friends are hanging out in the old calf. One is a genius, one is ethical, and one is just really, really poor. But little do they know, their peaceful world is about to be shattered by the presence of a mysterious stranger. Bum, 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 bum. The scene starts with a simple everyday chess match. Pawn to d4.
You always leave your pieces so vulnerable.
But every time you take one of my pieces, I take two of yours.
You must not be a libertarian.
The mysterious man approaches. Who are you?
I would tell you, but I don't have a name.
Don't have a name. What are you doing here?
I have something that belongs to me. This is a quantum box. Inside it is a button. Using a wave function, it will kill someone that you don't know, but it will give you $100,000. Think about it carefully. I'll be back.
Whoa, that was strange.
What are you gonna do?
I don't know, it was so weird. I mean, we don't even know if this thing's gonna work or not. What do you think I should do?
I don't know. I don't think you should push the button.
Why not?
I don't think you should be able to put a price on somebody's life like that.
I mean, I would agree, unless that price is $100,000 freaking dollars.
I mean, you can't buy a life for free, can you?
Yeah, but there's so many lives out there. There's 7 billion people in the world. Okay, guys, let's assume that we really have a quantum box here, right? That means that every person in the world, which is 7 billion people, will be represented as an eigenstate in this wave function. The normalization constant for such a wave function would be so small. Okay, if we calculate it like this, then a squared ends up being, or a, the value of a, equals 1 over square root of 7 times 10 to the 9. Do you have any idea how small that is? Ethical student?
It doesn't matter. What are you trying to say? Whoever died, they shouldn't have died anyways.
So this is how you calculate the probability that one individual person will be chosen. So first, this is our wave function for psi. And to find the probability that one particular person will be chosen, we set that one person in a bracket with psi and square it. That equals the one particular person times the psi squared. And that's this line. First, and then, next we will distribute the particular person throughout the psi wave function, and that gives us this. Since this equals 1, because they're the same individual, and these all are 0 up to 7 times 10 to the 9th people, it breaks down to this, and then 1 over the square root of 7 times 10 to the 9th squared gives us this probability.
Just look at this probability. Student, it must be so easy for you having grown up with money. Next year, I'll be going to college. I have to pay for it by myself, and I could be in debt for the next 20 years. Do you have any idea what sort of burden that is?
I may not be in the same shoes as you, but prioritizing your time over somebody else's life is extremely selfish.
Let's calm down, okay? We don't even know if this box will work or not.
Think about this for a second. As you mentioned, let's say this box uses a wave function to determine who it kills. But what if he or she is a hermit?
I see where you're going with this. If a tree falls in the forest and no one's around to hear it, does it make a sound?
Duh, it's going to cause vibrations in the air, making sound. Let's get back to the hermit. If a man dies in a home and no one is around to observe it, does he really die? If the universe can't determine the resulting eigenstates, then the wave function remains only a probability.
So then, would I still get the money?
Guys, this box doesn't even open. There's a lock on it, but no keyhole. But there's a window here with some copper plating and hooked up to a circuit. On the bottom it says 5 volts. I think it's some kind of puzzle. I'm guessing it's a photoelectric circuit, and the box opens with 5 volts differential. Can one of you look up the work function of copper?
The work function of copper is 4.7 electron volts. Look, I've just done the calculation on the board. Using this equation, Ke max equals Planck's constant times frequency minus the work function of the metal. Since the work function of copper is 4.7, that's the value that we use in this equation. And since the box needs 5 volts differential to open, that's what we used here. This is Planck's constant. Now, first, we converted 5 volts to electron volts using this number, and then multiplying by this constant. Then we changed the equation from frequency to wavelength using this equation here. Frequency equals the speed of light over wavelength. Solving for wavelength, we got 128 nanometers.
Where are we going to get that wavelength?
Well, since this is the wavelength of a ultraviolet light, we have to use an ultraviolet laser to open the box. Look, I have one right here. This laser has a wavelength of 128 nanometers.
I'm opening the box right now. Oh, it's open! Guys, I'm gonna press it. It's you again.
I have for you $100,000.
Thank you.
But I'm gonna need the box back.
Why do you need the box back?
It will go to someone else. Someone that you don't know.
Wait, I don't get it. If I used the box and I killed someone and this death was observed, then wouldn't the wave function collapse to the same eigenstate over and over again in the future?
No, because the wave function of the box only accounts for people who are living.
Oh, so you're saying that the wave function would change each time we use the box?
Yes.
Can one of you look up the work function of copper? I guess I'll look it up myself. He says, stop! You can't do that! Why are you smiling? You heard the sound.